Hi guys, I wanted to make a video doing an easier momentum question. I think that these questions can actually be really fun, so let's get into it. So in this scenario, I have a block A of mass 10 kilograms moving at 10 meters per second directly to the east, and then I have a block B of mass 3 kilograms moving at 20 meters per second due south. And these blocks are going to collide and stick together. So something to notice about this situation when we have two blocks colliding and sticking together, this is a perfectly inelastic collision. Okay, so that's not too important to our problem, but it's good to know what this type of collision is called. Okay, so now let's get started solving our problem. So because we know that momentum is a vector, we want to break it up into its x and y components to do our calculations. So let's start with the x. We know because this is a collision that our initial momentum is going to be equal to our final momentum. Okay, so now we have to think about initially what are our momentums moving in the x dimension. So in this scenario, I only have block A moving in the x dimension. So that would leave me with the mass of A times its velocity equal to my mass after they collide, which is just A plus B, times its velocity in the x dimension. So then I'm left with my velocity in the x dimension being equal to my mass of A times its velocity. I'm getting rid of the vector notation because I know that it's positive because it's moving to the east, divided by A plus B. And if we plug this in, we get that 100 over 13 is equal to 7.7 meters per second. All right, so that is our velocity in the x. Now let's move on to the y. All right, so starting the same way, we know momentum is conserved. So our initial momentum equals our final momentum. The only block that I have moving in the y dimension is block B, so we can ignore block A, and I'm left with B times the velocity of B equals A plus B times the final velocity in the y. All right, so now I get that negative B times my initial velocity of B. And notice how I made this negative because B is moving due south, which is in our negative y direction. And so therefore the direction of my velocity is negative. And then over A plus B. And so then I get that my final velocity in the y is equal to, well, if we plug this in, I have negative 3 times 20 over 13, which is equal to negative 4.6 meters per second. All right, so now we found our velocity in the x and y, and we can actually start doing vector addition to find what my total velocity is. So I'm going to start with my velocity in the x, which is positive 7.7. My velocity in the y is negative 4.6. So this is going to be my resultant right here. All right, so if we do our Pythagorean theorem, we get that, so we have 4.6, 7.7. We get that our resultant is equal to about 9.0 meters per second. But it can be tempting to stop here, but we're not actually done because we have to account for the direction of our velocity. So if this is my angle theta, we need to find in which direction our velocity is pointing. So I can find my direction by saying inverse tangent of 4.6 over 7.7 equals theta. So therefore theta equals, let's see, so if I do inverse tan 4.6 over 7.7, I get about 31 degrees. So I know that theta is 31 degrees, and then we notice that if we have our little compass here, north, south, east, and west, that our resultant is acting south of east. So my final velocity is just equal to 9.0 meters per second at 31 degrees south of east. All right, and this is my answer. I won't forget my vector notation. So that's it for this problem. It wasn't too bad, as you can see, and I hope this video was helpful, and I'll see you in my next video.